just see the diagram. So F1 and F2 are the lower and upper cutoff frequencies for a single stage. The F1 dash and F2 dash is for the lower and upper cutoff frequency for n is equal to 2, second stage. Okay, so that is going to be the relation between F1 dash and F2 dash. So this magnitude of 2 power n for various values for n is given. When you put n is equal to 1, that root of 2 power 1 by n minus 1 will become 1. So your f1 dash will be equal to f1, f2 dash will be equal to f2. When f is equal to 1, this number square root of 2 power 1 by n minus 1 will be this square root will be equal to 1. Okay, the square root will be equal to 1. So f1 dash will be equal to f1, f2 dash will be equal to f2. When you increase, when you put n is equal to 2, you see it is 64.64, or I can say the bandwidth is decreasing by 0.64. 64% of the first stage only the bandwidth you are going to have. When you put n is equal to 3, it is 0.51 or 51%. When you put n is equal to 4, it is 0.43 or 43%. When you put n is equal to 5, it is 0.39 or 39%. So when you put n is equal to 2, you can see the upper cutoff frequency is lower than the original frequency by 64%, and the lower cutoff frequency is increased by 1.56. So the graph becomes narrow. When you put n is equal to 3, the upper cutoff frequency is reduced by 0.51 or 51%, and the lower cutoff frequency is almost 2 times the single stage value. So you can see as the value of n is increasing, the upper cutoff frequency F2 starts reducing. The lower cutoff frequency F1 starts increasing. So this will result in the bandwidth. To start dropping. So remember, in multi-stage amplifiers, gain will be enormous. Gain will be product. You will be multiplying the gain of individual stages. But what you have to sacrifice? You have to sacrifice the bandwidth. So how many ever stages you are going to increase, that versely your bandwidth is going to decrease. So a decrease in bandwidth is not always associated with increase in number of stages if the mid-band gain can remain fixed and independent of number of stages. The general rule is if the number of stages are going to increase, the bandwidth will decrease, but this is not always true. So if you can maintain similar parameters in all the amplifiers, then you can also conserve bandwidth also. And there are amplifiers, which cascade amplifiers, which are going to have high gain and larger bandwidth. So that is possible when you ensure that every stage of your amplifier is going to be identical to each one. Okay, so that is the main concept of multi-stage amplifiers.